Hello, and welcome to episode 38 of Cooking with Unity. I'm your host, Maximilian Moreau. With me is my tech, Philip Wilson, as always.
Yep, I am here. Yet again, you thought maybe I wouldn't be here, but I am. I'm still here.
So, today we're starting with something a little different. So this isn't Unity, this is Gary's Mod. And the reason we're here is because I was having a little discussion on Unity 3D about decal systems, and we implemented a decal system for the walls, but I mentioned it's not really appropriate for characters because they're going to have sloping geometry and you're going to have a whole bunch of stuff sticking outside of their area if you use our decal system. It'll work, but it won't look right. And there were some questions about how to handle a decal system that's not expensive to the rendering, and it's not expensive to your budget as well. And so I'm going to be basically showing how to do that in Unity. But first I wanted to show you a quote-unquote real game and how they do systems like this, and we're going to use some of this as inspiration for what we're going to be doing on the show. Now, before I continue, this is important, I'm going to be spawning a body from a character from Counter-Strike, and I'm going to be shooting him with virtual bullets, and he's going to have blood splatters on him. If you were watching this with your kids and you don't want to see digitized violence, please just skip ahead. I'll put a little time signature or something you can skip to on the video here. If you're not worried about that, don't worry about it. If you're a kid yourself and you don't want to see bodies having blood sprays on them, go ahead and skip ahead. I'm just going to be using this as information for us to use. This is kind of a behind-the-scenes type of thing. We're going to be looking at how they do it and not really caring about what the content is here. So, like, if you were behind the scenes at the movie Dusk Till Dawn, you're going to see body parts everywhere, but no one owns those body parts. They're just mannequin limbs, and it's all fake. This is just textures and polygons, so don't blame me about scarring you for life on this, because it's just art. So, what we're going to do... Oh, you're laughing about the art thing.
No, I wasn't laughing about the art thing. Games are art.
Games are absolutely art, and people who don't believe that haven't made any. So, we're going to spawn a...
no, I was laughing about the scarring, about the
Okay, this isn't it.
I saw a 3D model get shot with not real bullets. And
oh yeah, emotionally scarred by that? Yeah, okay. Yeah, hopefully that won't happen.
I'm hoping that's not the case.
So, we've got this Counter-Strike guy here, and we are in Gary's mod, so we can do a lot of crazy stuff.
Just going to point out real quick, he's not real.
Yeah, this guy is totally
Still
not real. He is polygons with texture mapping. So, we can shoot him places, and he will actually show little blood stains wherever we shoot him. And this is kind of cool, and you'll see that it's not perfect. Like, if we shoot in some places, you'll see where it kind of cuts off. Like, you can see there's this sharp edge there. And it's just based on how the UV mapping is done on the model, how this will look. And for the most part, it looks good. Sometimes it'll stretch out in certain places. Like, if I shot the bottom of his foot, probably... Oh, it still looks pretty good. They did... Valve does a really good job on this stuff. You gotta understand. Like, these guys are professionals for a reason. Now, I'm going to shoot his head here a little bit, because we're going to actually investigate what's actually going on here. So, it's really hard to see right now, but I can tell you right now already, now I did some additional research already, that this is not actually applying it to his texture directly. This is applying it on a layer above it. And the way you can tell right now is the texture resolution of these sprays is actually higher resolution than the character texture itself. It's hard to tell from this angle, though. Luckily, Gary's mod allows us to do a lot of cool stuff. So I've got this little tool called the inflator, and we're going to make his head gigantic so we can take a closer look at things here.
Comically gigantic.
Yes, comically gigantic here.
Yeah,
see, it is
going.
just a game. No one's
going.
head looks like this. So now we can see very clearly what's going on here. So we can see some of these sharp edges, which are much harder to notice when they're on the model at normal size. And you can see that the texture here is slightly higher resolution than the texture below it. And then if we get to the edge here, you can see... Let me make it a little bit bigger if I can.
Oh, comically even larger?
Yeah.
Yeah, you can actually see where the UVs are stretching, too.
Yeah, you can see where things are stretching, and you can also see that this layer is slightly above the texture layer here. There's this little gap between the two. This is actually just a transparent layer on top of the character here. So what's happening is... This layer is this empty... You go bigger?
Yeah, you just go...
Oh, I just got rid of him.
Oh, now he's gone.
How do I redo?
That is a good question.
I don't know how... I'm going to just make another one.
It's fine.
Really annoying. I don't play Gary's mod much, so bear with me here.
It's just appropriate for this.
Yes, it is.
Oh, you
super
shoot them
appropriate for
first.
this.
Yeah. Yet again, not real people.
Yeah.
Just a character model.
Alright, so we're going to grab the inflator again after I make all the noise in the world.
Yeah, well, this game does have noise.
Make it gigantic.
Yeah, just go big or go home.
I'm going to not hit the Z key because evidently that's just
Yep.
undo.
Apparently the Z key is the devil.
Oh,
Wow.
They have a little texture on the inflator gun on there, kind of like my my game. That little diagram that they stapled onto it. So you can see this. There's this layer. You can really see here. And what's actually happening is there's basically duplicated geometry, slightly larger than the whole model everywhere. Just slightly, just enough so that it appears above it. And then it has a texture map that's completely blank. It's just 100% zero alpha fill. And then they're blitting. It's a term I'm going to use a few times in this episode, so bear with me. Blitting basically is I need to look it up again.
Yeah,
Look that
I'll
up for
find
me.
it. Just keep going.
So that we can have the actual term. But basically, what it is it's taking a image, a bitmap, and putting it into another image, another bitmap. And so a blit is where you take an image from one place and put it into another place. So they're taking this image from one place, which is the blood source image, and then they're putting it on this texture map, and they're blending it with whatever's already there. So if you see,
Okay.
I don't know what I did there.
You can actually see that it really clearly on the ground where it's two separate textures.
Yeah,
actually,
there's that line right there because you can see the overlap, and that's just because it thinks the body's gone when I go too far to the right. It's not used to the head being that large. So yeah, it's pretty simple system the way this works, and we're gonna implement something like this on this episode. I'm gonna be skipping most of the AI stuff. We're gonna be doing more AI next week, I swear. I'm actually excited to continue the FPS project just because there's a lot we can do. And
by the way, BLIT stands for a bit block image transfer.
All right, bit block.
It's a blit.
A bit blit, yes. It's a bit block image transfer. So there we go, block image transfer. So let's quit out of this and go into Unity and see what we can make.
Start the cooking, so to speak.
Yes. So here we are. First of all, first thing you're going to notice is we got these null reference exceptions here. I'm going to fix this right now. We're just going to double click on this, maybe. And it's going to go to the wrong thing because this is still linked. Hold on. Sync mono develop project. I'm going to clear this. I'm going to move the camera. And it still has the wrong thing. I'm going to hit play. Well, 1 second, folks. I just got things in a kind of a weird situation here. I'm having the same problem, but that didn't fix mine. Oh well. I'll just go in where I know it is. So we're going to go into the zombie AI and on-draw gizmos, and we're just going to comment out this line because it makes the editor unhappy. We'll probably clean up some of this stuff later. And I'm also just going to make the zombie into a prefab and delete him from the scene so that we don't have to worry about him for right now. So we have this world, and we already have a decal system that spawns objects on the ground wherever we shoot. Let me turn off the gizmos here. But we're going to change it to a new system that actually is editing the texture itself, so that we can do character model based space stuff. So the first thing we're going to do is we're going to write a extension method to texture 2D. So let me explain why we have to do this first. Should have had this open ahead of time, but that's okay. We're going to be looking at blit in Unity. So there's this function called graphics.blit in Unity, and it's super useful. It basically allows you to take a source texture and then put it into a target texture. And the problem with this is it requires Unity Pro. It says right here. That's the little bit of text that you have to look for if you want to find out if it's available on non-Unity. If you try to use this, it will give you some license error when you run your program.
It'll just basically say buy Unity Pro.
And the reason is because it requires render textures, which are a Unity Pro feature, and it requires image space manipulation, which is a Unity Pro feature. That being said, we can still do it. We just have to implement some of the stuff ourselves, because Texture 2D I'll explain the difference between what we're doing and what we would be getting. So texture 2D, Unity. It has some functions here. It has set pixel, get pixel, set pixels, and get pixels, and then it has a 32 version of both of those. And so we can actually adjust things on a texture map. Now the difference between what we're doing is when using the blit operation, it's going to be using our graphics card hardware to modify the textures. It's going to be doing it very quickly, and graphics card hardware is great at this. Like, it's anything that involves a linear operation like image manipulation is great. When we use the get pixel set pixel stuff, it's not going to be using our graphics card. It's going to be using the CPU. It will be slower than the blit implementation, and that's by design. They want that to be a feature for pro users. They want you to pay the money for that. And I'm not trying to steal money out of their pocket by showing you how to do this. This is all completely legit. It is slower, however, and we have to implement a lot of this stuff ourselves. That is something that we could probably get for free in the blit operation. So what we're going to do here is I'm going to basically make a extension of the texture 2D system that allows us to take a texture and do whatever our texture thing dot blit, or whatever we call it, and it will have that function in it. So this is something we haven't done on the show before. It's super useful. It's a little advanced, but I know you guys can handle it. So we're going to first just create a new C# script, and it's going to be called, I'm going to call it Ghetto Blit Texture 2D Extension. It's a lot of words. It doesn't have to be that long. It doesn't actually matter what you name this thing, but it's descriptive. And I went with Ghetto Blit just because it's not great. We might rename it if it becomes less ghetto later in the episode. But this thing's right from the
regardless,
ghetto.
it'll be more ghetto than their
will.
Unity
No
Pro
doubt.
operation.
So we're not inheriting from mono behavior. We're going to change this to a public static class. Because we need to do this to do an extension thing, and we're going to get rid of our start and update functions because these mean nothing to a mono, a non. What was the thing?
Non-mono?
Yeah, they had a whatever we just deleted there.
Mono behavior.
Mono behavior. It does. Those only apply to mono behaviors. So what we're going to start here is we're going to do a public static void ghetto blit.
Wow.
And inside here, so to extend a method on another object, all you have to do, this is going to seem really stupid and simple and kind of strange semantically, but it just works. It's a C# feature. This is something that I wish was in C++. You just do a this followed by the type that you want to extend. So we're going to do, as the first parameter, so we're going to do texture 2D, and then you have to give it a name. I'm going to call it texture. So
why was this a static class?
So this has to be a static class in order to be an extension class. If you, as a matter of fact, I'll get rid of the static class, and I'll show you why.
And why is the function as well static?
Let's do both of these.
Yeah,
let's do it both. It may not even have to be static in that case, but I think it does. All right, so first off, we already have an error here.
Yeah, it's because you took away static.
It says, indicates the method does not return a value, return type of void. No, that's not. What's the actual error? Extension methods must be declared static.
Wow.
So that's why. So, and if we hit save here, it's probably not going to give us a line in here, but if I go in here, it's going to say, extension methods must be defined in a non-generic static class.
Awesome.
So, public static. So it gives you a good error that tells you exactly what's missing.
It tells you exactly what's wrong.
So yeah, that's why. Because that's why. So this is how you do it. So what this does, I'm not even going to do anything now. We've just done this. So if we go into a script, I'm just going to choose a random script, apply decal on one shot. This is just a scratch area, real quick. Scratch area. We can now do, so if we do texture 2D, if we make a texture 2D text, we can now do text dot, now this thing had like get pixels, right? So it has get pixels, it has set pixels, and now if we type in blit, you'll see ghetto blits in here. Mm-hmm. We've just added this function to the Texture 2D class. It wasn't declared in the Texture 2D class, but we've extended the class with our with what we've done.
That is pretty awesome.
And so now we can actually work with this, and so anytime you work with the Texture 2D, if you have this file anywhere in your project, it will work. It will just magically work. So we're going to need a little bit more than just the textures. So what we're actually going to be doing is we're going to be blending a decal. So we're going to need another texture. So Texture 2D decal is what I'm going to call it, even though that's kind of mixing terms here, but I don't care. And then we're going to want where to put it in here, which I'm going to actually describe as a float X and a float Y. No, I don't have to type and float. You've done that before where you're just typing what you're thinking, so sometimes that's not good. So this is going to be our texture itself, which this you don't actually pass this as a parameter. It automatically gets passed when you are referencing it. It's whatever the texture that you're calling blit on.
Why wouldn't this just be a vector too?
You could do a vector 2. As a matter of fact, let's do a vector 2. Let's do it.
I don't know if there would be a big difference.
Honestly, it'll save us a line in using this in the way that we're going to use it. So I'm going to go ahead and do it. Why not? Vector 2. Vector 2 position.
I was just curious.
So yeah. We're going to be using a raycast to get that information and feed it into there, and the raycast actually does provide a vector 2 in this case. So,
Perfect.
So this will make it easier for us. I actually should have thought to do that myself, so thank you very much.
You're welcome.
Yeah, always helpful on this show.
I try.
So
sometimes it's just dumb. But.
So what we're going to be doing here is we are going to be put decal on texture. That's what we're doing. We're putting the decal on the texture, and we're going to do it in. We're going to be It's only going to be a few lines to do this. It's not as big a deal as it seems, and we're going to be using the get pixels and set pixels command. So first, we're going to have a color array. So color array. We're going to call this the decal colors. And we're going to set equal to decal.getPixels. So get pixels, if we mouse over here, you'll see that it returns a color array, and it also has 3 overloads. We're not using any of them. We're just getting all the pixels in the decal colors and applying them to this array. It's just an array of colors. And it's a linear array. So I don't know if it starts at the top left or bottom right. It doesn't matter. We don't have to worry about that because the functions that we're using were built with feeding each other in mind. Like this was already kind of the designed use of these things. Mm-hmm. So we have the decal colors. We're going to also need a float decal width. We're going to set this equal to decal.width. And we want to float. Actually, these are ints. Sorry. Int decal width.
Yeah.
And int decal height equals decal.height. This is just so I don't have to keep referencing the decal too much in the expressions here. So what we're going to do is we have a function called setPixels. So we're going to do texture.setPixels. And there's 4 overloads on this. So there's one that just takes an array of colors. There's one that takes colors and a MIP level. We're not going to worry about the MIP level. There's one that takes X, Y, block width, block height, and color. This is actually exactly the one we want to use because this allows us to set a position to put the pixels, and it allows us to set the width and height of the total paste in. So we're basically putting a square into, well, it doesn't have to be a square, a rectangle or some sort of
any kind of
two-dimensional element into it. So we're going to do set pixels, and we're doing the third one here. So we need an X. So the X is going to be represented by, we're going to be using the position. So so this position I should probably explain. This is not going to be in pixels. This is going to be in a float, and this float is going to represent its UV space. So 1 is going to be the far right in the case of X. 0 is going to be the far left. 0.5 is the center. Which means that if we multiply this by an integer representing the actual pixels, we will get the offset horizontally or vertically in pixels that we're going to be applying this texture. Does that make sense?
I think so.
All right. So what we want is we want the X position based on this position and the width of our texture that we're blitting onto. So we're going to take the texture.
It's just like working with GUI components, basically.
Yes. So
when you're working on camera space, it's 0 to 1.
Texture.width times position.x. That's our X there. And actually, we're going to add something to that in a second here, but I'll get into that in a second. Texture.height times position.y. Block width is decal width. Block height is decal height. And then we just feed it in our decal colors. So let's just start with this, see what it does, explain some of the caveats and stuff, and some of the things that we're going to have to deal with on this, because there's actually a lot of detail work that's going to go into this.
Yeah.
So hopefully this will actually do something. Actually, it's not going to do something. We're going to have to do one more thing. I want to do it so that we don't have to deal with it later. We need to do texture.apply. What this is when you actually do get pixel, when you do get pixels, you get something immediately. When you do set pixels, it actually buffers it. It doesn't do it immediately. It does the actual rendering on the texture when you do apply. And it does that for speed purposes. In case you're setting a bunch of pixels, it doesn't do anything until it has it all cached and it has a nice organized thing behind the scenes. And then you hit apply. It's like, okay, save all that stuff, because this operation is actually expensive.
Mm-hmm.
When I say expensive, it's not noticeable when we're running it in the editor here, but this is one of these ones where I'm not sure how well this will run on mobile.
Oh, I have
it will
no idea.
certainly run better on mobile than a projector system, though, which is what some people might try to use for bullet decals, which will just destroy you on. It'll destroy you on PC, actually, if you do a bunch of them. Like if you're doing a whole bunch of bullet projections, it's ridiculous. So we've got this. So we're going to do a. I'm going to create a new script.
Argument 1.
Oh, there's a problem. Invalid argument. Set pixels. So let's actually do int, and then bam. And we're going to do that
Explicitly
setting
it to an int.
Yeah, this is a typecast, and we're typecasting it to an integer. This will evaluate to a float because the second value is a float, and when you multiply an int by a float, it goes for whatever retains the most data, which is a float. But we're going to be forcing it to an int. We may have, this may mean that we're off by one portion of a texel somewhere just because we're rounding. No one's going to notice. No one's going to notice. So hit save. Hopefully this will fix that. Okay, fixed it. Now we're going to need one more script to do this. I'm going to duplicate the apply decal on what's shot, and we're going to call it blit decal on what's shot. And we're going to rename it in here as well, because otherwise Unity will complain, because here the names matter because it's a mono behavior. A lot more matters when you're dealing with a mono behavior. So same concept, decals. But we're not going to be spawning them anymore. So the for each loop is still valid. I'm just going to comment this stuff out for now. We're probably just going to delete it outright, but I don't want to delete it in case it has some methodology that we want. So what we're going to do is we're going to take, so we need a, so we have decals. This is no longer going to be a game object. We're going to need a texture 2D on this. And what we're going to do is we're going to get a texture 2D original material equals renderer dot material dot main texture, and we're going to have to actually typecast this to a texture 2D. The reason we have to do this is because internally the main texture is just a texture, which is compatible with texture 2D. But it's a texture 2D is a superset of texture, so we can convert very easily into it. So just suffice to say that we'll need that, otherwise we'll get a similar error to what we were doing before. And so we have an original material. So we're going to take our original material. Now we have this raycast hit info. We have this because it was being passed in by shots, so we don't even have to worry about this. This adds exactly what we want. Mm-hmm. So original material dot blit, so we have ghetto blit, and then here we have decal and position. We need our decal, which is just decal, and so this is we'll fix what this is doing in a second.
Yeah.
So we have decal, and then we have a vector 2 position. So the vector 2 position is
Well, it's info dot something, right?
yeah. We want info dot texture coord. And what this returns is a vector 2, and this is in the 0 to 1 space, and it will give us what we want. So we're going to do that, texture coord, and that should be all we need to do. So I'm going to just go ahead and go to our floor. Oh, cannot convert type. Game object, what we're doing. Oh, need to change it here too for texture 2D, decal, and decals. So we hit play, and oh, we don't hit play yet. We haven't attached this to anything. So I'm going to go into our floor. I'm going to remove the decal system that we already have. We're just going to remove this entirely, and we're going to throw in our blit decal on with shot. And we're going to actually, it's not going to work the first time, and you'll see why. So we're going to shoot, look at the ground, and click, and nothing at all is going to happen. Make sure that. Not what I was expecting. Oh, it's because we didn't set a decal.
That would be a good reason why it wasn't showing up.
So it's doing a for each loop. Nothing's in there. Skips the whole loop. So we're going to throw this into the decals. We're going to hit play, and then we're going to shoot at the ground. And bam, there we go. Unity exception. Texture bullet hole is not readable. Texture memory cannot be accessed from scripts. You can make the texture readable in the texture import settings. Pretty comprehensive error, actually. So we go in here, and this is a texture import settings right here, bullet hole import settings, and it's not there. Where is this thing that it's talking about? So go down to advanced, and then we can get all the twiddly bits.
Wow.
And what we need is this read, write, enable. We just click that, hit apply, and I'm just going to make all the mistakes right now because I want you guys to see this. So we're going to click it again. Oh, crappy floor tile is not readable. I forgot that's what we called it.
Oh, that's kind of funny.
So that's our crappy floor tile. So we go into advanced.
Do the same thing.
And we click read, write, enabled. We hit apply. We do it again. We shoot. Unsupported texture format needs to be something that's not compressed, is what that's actually saying. ARG, RGBA 32. So what I'm going to do is I'm just going to go on both of these, and instead of automatic compress, I'm going to do automatic true color and hit apply. So now we should get something. We got something. Now it's not what you expected. It didn't go under where my cursor was. And it's repeated. It's kind of curious. It's one of these things that's just kind of curious. Right. And you know why this has already happened. It's because our texture is tiled, which means that wherever we shoot, it's going to get kind of a weird texture coordinate, place it into the texture at that coordinate, and it's going to repeat a whole bunch of times because the blit doesn't know that the texture is repeating. The blit just assumes that it's a single contiguous texture. So for the time being, we're going to turn off the repeat on the floor tile here. We shouldn't have called it that just to be kid-friendly, so but it is funny. So we're going to hit play again, and now we're going to shoot. And bam, there's our bullet hole.
Yeah, it is.
It is gigantic. It has this huge, ugly white space, which we're going to talk about in a second here.
And
it's also the corner. You notice that it went to the corner. So let's fix the corner thing first, and then let's discuss all of the various things here.
Big old bullet hole.
Yeah, you can still see it. I've stopped playing, and you still see it there. I'm going to discuss how to fix that little issue, too. So, like, if we hit play again, it will already have a bullet hole there. Kind of awkward.
Mm-hmm.
I'll show you how to fix that, too. So, so let's go into our Ghetto Blit 2D extension here, and we're going to change in the Ghetto. Okay, I'm not doing it. So, texture width times position X. So we want an offset. So right now we're just putting the corner there. That's actually what we've told it. That's the corner. Because this doesn't take, the X and Y that this set pixels takes assumes a corner. It's not assuming the center. So all we need to do to make it a corner, a center as opposed to a corner, is just add the decal width divided by 2. And we want 2, not 2.0f, because this is, we want an int out of this. And then we do the same thing on here, plus decal height divided by 2. So if we do that and hit play, Actually, first, so we've got this bullet hole showing up on here. I'm just going to change this here and change it back, and then hit apply, and it'll go away. And we'll fix this in a second. So now when I shoot, it should be a giant bullet hole. Oh no, I wanted minus. I lied. I wanted minus. You knew that already, didn't you? You were laughing at me inside.
Nope, I didn't.
Okay.
That's how I figure out which one to do.
Exactly. So let's do this again. I'm just gonna bloop bloop, apply.
Yeah, the last week's show,
And
you know,
then
where I did the subtracting the node position from transform dot position. Yeah, I had those inverted initially. As I said, I prepared a little bit ahead of time.
Excellent.
But yes, that happens all the time.
So I'm going to shoot, and bam, that's pretty much the center.
And
it's
you made a
going where we
black
want
hole.
it. We have this huge black hole. It's not nicely alpha masked. We're not used to this. We're going to start panicking and screaming and tearing down buildings in a second here because it's not working right. But I'll show you why it's not working right. It's actually working kind of in an interesting way. So we have this. It's shooting in the right position. It's gigantic. Now, we've come to caveat 1, and this is part of the reason that Valve has decided to make a second layer of geometry. Your decals are dictated by the size of the texture that you are blitting into. We are not doing any transforms based on world space here. We're not doing anything magical here. We are just literally, if we have our bullet hole is 32 by 32, and our texture is 256 by 256. If this was a twice as big texture, it would look half as big. If this was half as big, it would look half as big. It's based entirely on the ratio of the texture. And so if you don't want to have to worry about that changing, like what if you decide halfway through your project that you're going to double the resolution of the textures for your dudes? All of a sudden, your blood sprays are going to look smaller than they were before. And you're going to be like, wait, what? And then you're going to realize, oh, yeah. Oh, now I have to change all the textures for that. So putting it on another layer protects you from this. It gives you a little bit of buffer.
Yeah, where they put it on a whole nother character mesh that was just basically surrounding.
We're still going to work with this right now because as we work through this, we're going to make this more and more robust.
Plus, it would also fix the problem of it writing directly to the...
would partially fix that. It would partially fix that. I'll show you why. So I'm going to fix that problem right now, actually. So we're going to hit apply. That's not the one I needed to do that on. I need to do that on this texture because this is the one we modified. So it's re-imported. So here's our problem. We have this original material, and then we are changing it. And if you notice, like, sometimes we do transform stuff where we do old transform. We have to set the old transform to the new transform. The reason we have to do that is because the transform internally is a struct. A struct is passed by value, and what that means is when you say something equals something else, it takes everything that was inside that struct and moves it into the other thing. Texture 2Ds are actually passed by reference, and it's difficult to tell what's passed by reference and value other than it's a struct or a class. So these are a class, and they're passed by reference, which means that anything I do to this variable original material will be done to render it up mirror material or main texture. It's a pointer to that.
Yep.
And so if we want it to actually be a separate texture instance, we have to actually do a little bit more work. It's just like one more line, but let's do it. So let's do a texture 2D modified material equals new. Whoa, I didn't even type
awesome.
that. Double space, that's cool. I didn't know about that one. New texture 2D, and then it takes a width height. We just want the width height. So the width will be original material dot width, and height will be original material dot height. So we have this. So this is an empty texture that just happens to be the same size as the original material. So now we need to actually fill it with things. So we're going to be using those get pixel set pixel methods again. What we're going to do is modified material dot set pixels original material dot get pixels. And now we have copied all of the pixel information into the new texture. And then finally, at the end of all this, we have to set our modified texture, modified material. I guess I should have called it texture. I don't know why I'm calling it material. I'm mixing terms here. As a matter of fact, that actually bothers me so much, I'm going to fix it. because I do not want to confuse people any more than you are already confused about materials and textures, because there is such a distinct difference, and yet it is very subtle.
There's
it is huge.
Yeah, huge
it is
difference.
Gigantic, but it is at first it was subtle.
Original material there as well.
Thank you.
Oh,
and here,
and one more.
And one more.
Yep, get pixels.
Oh, thank you.
Mm-hmm.
So now we just need to make sure that the renderer is actually changed to use this new material. So this will be instancing our renderer. We're not worried about draw calls right now, but this will incur an extra draw call because it now has a new material.
Mm-hmm.
Equal, and I actually mean a material there. Even though we're changing the texture, it is actually a whole new material as well. Main texture equals modified texture. And we have to change one more thing. We want this to be the thing that we ghetto blit into.
In Unity, it seems like every texture seems to have a material, but not every material has a texture.
Not true. You can definitely have a texture without a material.
Can you?
Yeah. As a matter of fact, this would work even without having a material for our bullet decal. But in typical use, you're absolutely right. Typically, there's not much use for a texture outside of putting it in a material.
I see what. Yeah.
So when I click here, we got a new
be.
bullet hole. It works still, and if I stop hitting play, you'll see that it doesn't have the bullet hole there. If I hit play again, it's no longer there. That's because it's no longer putting it into that texture itself. It's not putting it into the prefab.
It's not modifying that texture.
What did I just undo? All right, I'm putting this back in textures. I clicked and dragged something.
Yeah,
oh no.
I've done that.
So at least it didn't rename anything.
Yeah, you're actually modifying a copy of that.
So I'm modifying a copy of the texture now. That's what we're doing here. This is just copying the texture into it. So let's answer one of the questions. Why is that white stuff there? So this texture, if you remember correctly, we can shoot a wall here, and it will actually not show a ugly white border. It's because the white there, even though it shows up as white in this little thing, it's actually transparent. It's actually transparent, and when we shoot the wall, it obeys the transparency. Now, the reason it's obeying the transparency is because the material obeys it. Right now, we are not doing that with our floor tile. Our floor tile material is just a diffuse shader. It ignores the alpha. So, for science, we're going to do this, and I'm super excited about this. I know this sounds really dumb to be excited about it, because I'm excited about a bug that you guys are going to see. So we're going to shoot the ground now that it has transparency. All right, something fascinating has just happened. This is actually transparent. We can see the sky through here.
Mm-hmm.
You could see other objects through here even. What we've just done is we've just punched a hole through a texture using another texture. And the reason we have is because set pixels doesn't do a blend operation. It takes whatever information is in there and applies it. And that includes the alpha information. So this is alpha information says be a hole. It says that this is a hole, this is semi-transparent, etc. And so this bug is a bug that you should remember in the future. Now the thing is, the reason I'm doing this show is because anyone can make games. And the difference between the people who are really good at making games and the people who aren't good at making games is time and practice. That's the only difference. And the reason is because there are millions of tools out there. There are more tools than you will ever be able to learn in your whole life. And you can make up tools. You can just make up tools while you're working on this stuff. You might have something that's very specific in mind and make a tool for it. And so keep this in mind. If you have a game where you wanted to punch through a hole with a bullet in a wall and see through it, this is a way you can do it right here. Just like what you would do is you would make the center of it transparent, so it looks like a hole as opposed to the edges of it transparent.
Mm-hmm.
And it will just punch through, and it will be awesome like that. Now, so now that we're out of the way on that, what are we going to do to fix this? So one of the ways we could fix it is the valve method, where we duplicate the geometry. And if we've duplicated the geometry, this isn't even a bug, because we're adding things to a texture that's transparent. We're not punching holes in a texture that's transparent. Now, it's not perfect, because if you shoot another bullet on top of an existing bullet, it'll cause some cutting and stuff. So we're still going to want to fix this issue, but that dodges it pretty well. So let's work on fixing this. So we need to actually blend one texture into the other texture, taking into account alpha, which means math. It's not even that exciting. So I'm excited about this episode because I'm going to show you some of the internal stuff on what's actually happening. Like, the things we ask Unity to do, it does a tremendous amount behind the scenes. You have no idea. Like, computers, like, in a frame in a video game, I don't care what video game it is. In a single frame in a video game, more calculations are going on in that frame than you will ever input into a calculator and that you have ever done math assignments for in your whole life. And that's one frame. There is so much math that happens in games, especially now, that it is mind-blowing the amount of stuff that's actually going on behind the scenes. So we're going to actually look at one of these little behind-the-scenes things here. So we're going to look at our, what is it? The Ghetto Blit Texture 2D extension. So set pixels is not what we would need. We need a blend pixels method. And so I'm going to actually just make another extension method here. So we're going to do public static void blend pixels. And I'm going to make it look very similar to the set pixels method. It's going to take a position information, and it's going to have the decal width, decal height, and the colors, and then it's actually going to do a blend operation rather than the set pixels. So it's going to take, first of all, it needs itself. So it's this is how we know it's an extension. This texture 2D texture. Then we're going to need our int, our integer position in there. So that's what is it called? Just int x, int y, int decal width, int decal height, and then finally color decal colors. Now, I did not practice this before the show, so this is going to be one of these magical places where we find out what I'm actually worth as a programmer. We're going to find out. It's not much. Not much. All right. So, I found the method here, set pixels blend. Let's see if this set pixels not transparent. So this is a person having a similar problem to us. And there's a painting stencil on a surface. So I'm just putting this out there that you can search for this. Like, this is important. Like, all I do is research. Like, whenever I need to find a problem, I just search for things until I find something that is close to what I need.
Yeah, what's interesting, it seems like, about the internet now as a utility is you probably aren't the first person to have this problem.
Exactly. And if you are, congratulations.
Yeah,
you
seriously.
are bleeding edge. Like, seriously. Or you have not worded it very well.
I've found so many answers by just using Google to search for this stuff. Like, it's amazing.
So here's the information right here. This is actually what is happening behind the scenes in a blend operation. So when you have something that's alpha 50% and something else that is alpha 100%, you put the alpha 50% in front of it. It's taking some of the value of the 50% thing and putting it upon the other one. What it's doing is adding its color with a weight of 50%. That's really what's happening. And so the final color is source color times source alpha plus destination color times 1 minus source alpha is the inverse term of it. This is actually what's going on behind the scenes. Now, if you've played with OpenGL, you'll know that there are actually other blending modes. Like additive blending is just straight up add the values and then maybe use it as a weight into the values, but it would just be an equal weight on both sides. Maybe it's not. There's a whole different. As a matter of fact, in OpenGL, you can actually set what the function is even doing. You can just literally program what you want the comparison to be. Mm-hmm. And so the default comparison though is alpha blend, and it is this calculation. So here's the little bit more explanation: RGB color of the texture you're applying times alpha color of the texture you're applying plus RGB color of the texture in which you're rendering times 1 minus alpha of the texture that you're applying. So let's do this. So we're going to basically do this one pixel at a time now, because we can't just assume that every pixel is different. So we're going to have a for each loop. For each pixel, color in decal colors. So we have the color and decal colors. So each one of these we're going to apply into the texture. So we're going to start at the upper left or lower right or wherever it starts. I don't care. I'm just going to start writing into this thing, and we'll readjust things if it's upside down. Actually, we're not even going to notice that. But if it's upside down, just assume other things that we're not assuming right now. So what we're going to do is we're going to be basically ultimately set texture dot set pixel. Okay, we need an X and a Y. So let's see. Int X equals 0. Oh shoot! We need another. So we already have an X and a Y. So int. I'm going to call it loop X and loop Y, because these are the ones that we're going to be keeping track of what pixel we're on. And so for each one of these, we're going to do loop X plus plus. Actually, we're going to do this after we do everything. Yeah, I'm really organized now, you can tell. Just so I don't confuse things too much. So loop X plus plus, if loop X is greater than... Is it greater than or greater than or equal to? I think it's greater than or equal to decal width.
We'll find out soon enough, won't we?
Maybe. It's going to be trickier to tell this one, but...
Well, it counts 0, right?
It counts 0, so I'm pretty sure it should be greater than or equal, because I want it to...
Yes, you want it to be greater than or equal.
So, loop X,
once it hits
if it's greater than or equal to decal width, we now increment loop Y. And we set loop X
to 0.
Back to 0. So what this means is we've done the first one. So the first one is 0, 0. The next one will be 1, 0. The next one will be 1, 0 until we get to the width, in which case we go to the next line, and it's now 1. It's now 0, 1, 1, 1,
2, 1,
2, 1, etc. And then it goes to yeah. And so that's all this is doing. It's just keeping track of where we are in our pixels. So ultimately, we're going to set pixel. We want the loop X for the X, loop Y for the Y. And the color should be, we're going to need int index equals 0. So index, we're going to do just the same thing with it. Index plus plus. And this is just going to be the flat index into our color
basically
array.
the color in the array.
Yeah, exactly. So this one will be decal colors index. So this is not exactly what we're doing, because decal colors, right? So what we're doing right here, if we were to, as a matter of fact, let's test it. Let's test to see if this works exactly the way we want it right now. I'm going to, instead of using set pixels here, we're going to use blend pixels. And this is still going to have the exact same problem, because this is actually doing the same thing as set pixels right now. It should be, at least. So let's see if it works. We're going to hit play, we shoot, and it's off. Let's see how far off it is. It's way over in the corner. We did something wrong. All right. So
let's find out what we did wrong.
Oh, we didn't actually do an offset into this. So
because of the...
So we want this to actually be offset from here. So it's actually going to be loop X equals X, loop Y equals Y.
Remember to set X back to X down there. Loop X down to X.
Yes, we're going to have to set loop X to X. And it's not going to be, if it's greater than decal width, it's going to be X plus decal width. And then loop Y. I don't know what this will do on the edges of the texture.
Well, let's figure it out.
We'll figure it out. That should be good enough. Let's see if that will fix our problem.
And we might have to have a case.
Oh, that fixed our problem. So let's see what it does on the edge, just out of curiosity. I'm going to have to bust down a wall or something. I'm also going to have to make my player movement speed faster because otherwise I'll just
forever
die from old age before we get to the edge of the platform.
That is true.
Oh, actually, let's just be clever. That'll work.
Yeah, that is true.
So
as long as you don't fall off the world.
I'm just curious what this will do. Bam. Looked okay to me.
You know what? That was about.
It probably
the
goes
best
to the other
case.
side, doesn't it?
I don't know.
Probably does. Yep, it goes to it wraps to the other side.
Did it?
Yep. See that little splotch there?
Oh, it did. That was not what I was hoping for.
Yeah. Well, that's actually what I was expecting, though. So this is actually offset by 1 pixel and on the other side for reasons of wrapping.
That's how it works.
That's just how it works. I'm not going to worry about clipping. We're not going to fix this episode.
You could fix this. But
yeah, this is very fixable. Look, the word to search for is clipping. Like if you want to clip to a surface, that's what this is. We're not going to worry about it right now. As a matter of fact, it may even be advantageous on a character because on a character model you might want it to come somewhat revolve around a little bit,
depending on
how you set the UVs up. It's probably not going to hurt you in either in any case. So, but that does work. That's now doing the same thing as we were doing before. Now we want to actually do the blending. So we're going to have a color array, we're going to call it, what are we going to call it? Blended colors. And we're going to actually declare this above here. We don't want to declare it every time that we're in the loop. Color blended colors equals, I'm just going to set it to decal colors for now because it's going to be the same size as decal colors, so might as well just start with that. Mm-hmm. In the case of color is a struct, so this automatically is a value link here. And actually I think arrays are kind of work that way anyway. I'm not going to call an array a struct because I don't want like James or George to see this and maybe like kick me in the balls next time they see me. So I try not to tell too many lies on the show. Sometimes I simplify to the point of a lie. I apologize in advance for that. I try to tell you guys when I'm doing that, but I want to try and keep the terminology as good as possible. So we need to do this blend. So the pixel. Let's actually make a color, just for organization's sake, color final pixel color equals, so let's start this one at the color of the position that we're going to be setting. So texture dot get pixel loop x loop y. So this already is our original color here now. And so now we're going to blend on top of this. So the final color is, all right, so this is, actually, let's not call this final pixel color. Let's call this texture pixel color. Let's make another color called color decal pixel color. And this one's going to be decal colors dot decal colors index because we don't actually have here we have a texture 2D, here we actually just have a list, and this index should represent the proper place in our list that we want. So this represents one color, this represents the other color. So the final color is color final pixel color equals, let's go new color, and so it has float R, float G, float B, and float A, and float R, float G, float B. So we're going to do the full shebang. I don't know what the alpha should be. I guess I may have to think about the alpha. Maybe we'll just worry about the colors for right now. So So color R is going to be texture. Actually, let's do decal pixel color dot R times decal pixel color dot A. So what this represents is color of the texture you're applying times the alpha color of the texture you're applying. So that's the first part. Okay, plus texture pixel color times 1 minus decal pixel color dot A. And we need this to be dot R here. So that's our R thing, and then we just do the same thing for G and B.
I don't think you'll need to worry too much about the alpha, at least right away.
I don't think I will either, but I want to have a good value for it.
Well, I mean, it should never be low. It should never be less than 1.
It should never be less than 1?
The alpha of the final image, right?
Well, let's say that we were doing the valve method where we had a transparent
Okay,
thing.
well, in this case...
it doesn't matter. In this case, it doesn't matter. But we want it to be right for the other case, too. We'll not worry about the other case just yet. But,
yeah. We're kind of getting ahead of ourselves.
We are. We like to do that. So, I'm going to go ahead and put, do this
new line.
With new line style. So, bam. As a matter of fact, I'm going to do this here. So that it'll...
Oh, it looks real pretty.
Look real pretty. And then we copy and paste this as well.
Get rid of that comma.
B and B. And actually, let's get rid of the comma and just end it there. We'll just let it deal with whatever the other thing is. And now, instead of doing decal colors on index, we're going to do final pixel color. So let's see if we got a blend, or at least some form of a blend. Oh,
look at that! Got a form of a
amazing, amazing. I just love it when a plan comes together.
Mm-hmm.
That's all I have to say about that. So
we should probably think about that alpha situation as well, though.
Yeah, let's see what we need to think about. And so it even blends on top. Oh, look at that! That's awesome. That white line is actually part of the texture because it's this really stupid little spider shaped thing. So that's supposed to be there. I swear. It's working. Look at this. This is totally working. Now let's do a non-trivial case. So let's do a sphere, and let's actually do a comparison between our two things here. So where are we putting this sphere? I'm just going to make it a big sphere. I'm going to make it 2 by make it 3. Let's make it 5. Not 35. 5 will be plenty.
35.
And let's put it somewhere that we can see it.
Right on the player.
Let's not put it right on the player. Let's put it over here.
Because that's exactly where we couldn't see it if that was the case.
Exactly. And we're going to need to make sure this thing has an actual texture, which I don't think it does by default. Maybe it does. Let's just... yeah, we need to give it a texture. So let's make a new material, create new material. Actually, no, we'll just use the floor tile material. Why not? Delete. We're going to use the floor tile. We're going to apply it to our sphere. And then what I'm going to do here, we're going to call this our test sphere so we can find it. The first one we're going to do is I'm going to put apply decal on what's shot here. And we're going to give it our decal prefab. And we're going to see how this looks first. So we have this sphere, and we shoot it, and it doesn't. Okay, so it is actually working.
Oh, it is.
This is to be hard to see. So you can see that they're floating off on the way, and you can also see that that this isn't an extreme enough case. Like if we were dealing with a character with like a mouth or something, and you shot him on the lip, it's going to look really bad. It's going to attach in a very strange place, especially if he's animated and stuff. But it does work. So we can use our other system on this. But this is creating little objects and stuff. Now let's look at our other one. So let's remove this one. Remove component. We're going to throw our new bullet decal on what's shot. And we're going to add a bullet hole in here. So now when we shoot at it,
That is interesting.
Is it going anywhere? That works.
What are we missing here?
That's very interesting. It's not working. Not getting any console output.
Nothing.
It's totally working on this surface.
But why is it not working on that surface?
Curious.
Very.
Alright, so let's look at our collision stuff. Okay, so test spheres on default layer. The floor is on collision. Alright, so it's probably because something in our collision matrix is unhappy. So let's just try to put it on collision and see if it makes it work. No, didn't make it work.
No, collision was just
I know it was, but like
just for pathfinding.
Yeah. It's untagged. Weird.
And it's the same material, right?
Oh, do I have to? Yeah. No, it's because it's not getting an on-hit message because or wait, no, it should. What else does the floor have? It just has blit decal on shot.
I do not know. That is very odd.
Why is it not working? Alright, let's debug this. Blit decal on with shot. Let's just come in here and make sure that it actually is getting called at all. So we're going to connect in, Unity Editor, attach, hit play. Okay, it's in there. I typed in something naturally. That's just great. So let's see what info has in it real quick. So the UV is 0, 0 for some reason. Okay, that's not what we want. We want the texture coordinate. We're getting texture coordinate 0, 0.
So on the top of that sphere, somewhere on that sphere,
yeah, somewhere on the sphere is actually
it.
drawing it, but we can't. It's probably in a really awkward place. So it's getting 0, 0 for the texture position for some reason. There's no like rigid body requirement or anything, is there?
No, there wasn't a rigid body on the floor.
Oh, it's probably because it's not actually a mesh collider. That's the problem.
Oh, really?
So this requires a mesh collider, and the reason being is because the sphere collider doesn't know anything about its texture. It just doesn't know anything about it because it's not applied to the UV coordinate thing. So I'm going to replace it with a mesh collider. Typically, you would not want a mesh collider on a sphere, but in this case, we definitely do. And actually, I have to do it again because I was in play mode. So we're going to go back to our test sphere, which is
kind
the
of
actual
a ridiculous
sphere.
amount of polygons on that thing.
Yeah, yeah. But I mean, like, if you were doing this on a character, you're going to need to use the character mesh. So that's an appropriate use of the character mesh. So we're going to do a physics mesh collider, replace, hit play, and now we should. There we go.
We are.
It works. It totally freaking works.
A little bit like a Death Star sometimes, but that's okay.
Yeah. So this is now applying decals to it. There's no Z fighting. There's nothing we have to worry about because it's actually applying it to the texture. As I said, the size of it will be based on the size and shape of it will be based on the way the UV mapping is done, and the size of the source texture and the size of the destination texture and the ratio between those two. But we have it working. Let's make a. So we want to fix that other potential problem. Yeah, let's do it. So we need. Can I create a new texture? Is there actually a texture that is just default? No, I can't. So I'm gonna have to make something. I'm gonna make a 512 by 512 empty blank texture to work with. So let's just do that real quick. Pixelmator. Ho. You can do this in any program. I'm pretty sure this is not going to be rocket science. I'm going to make it. How did I say how big I was going to make it?
512.
512 by 512. Bam. And then all we're going to do is just select all, hit delete, and hit save. Most complicated texture ever. PNG. Blank. Put this on the desktop so I can access it easily. Throw it into our project under somewhere.
Would be funny if the desktop didn't recognize it as having anything in it. It's just a blank.
Right now, I'm just going to put it there. I'm now going to move it into here. We're going to need to do advanced. It's going to need to be able to read write. What was that?
Someone's talking on Steam.
Oh no,
probably.
Steam. I forgot about Steam.
Yeah, we all sometimes do.
I'm just going to force quit that or not. Hold on. Quit. Die. All right.
Oh.
So, what are we doing? Generate map apps, rewrite enabled. Hit apply here. Oh yeah, we want it to actually be a real color system, not something that's hard to work with. So now I have this blank texture. I'm going to create I'm going to actually put it on our sphere. And so our sphere should be, oh, it's transparent. Let's select it and hit play and then go gizmo so we can at least see where it is. I'm curious how this is going to work. I have that sphere selected, right? Shouldn't it show up in this thing? I guess gizmos is not enough. Alright, whereabouts is this thing? Where am I looking? I'm just going to put it in front of me.
Where is it? Can't see it now because
there it is.
Oh,
all right. So yes, we do need to fix an alpha problem because we're getting a.
It's saying that its alpha is 100.
So what I would say, let's try. I'm just gonna take a theory here. Let's take the highest of the alpha values between source and target.
That makes sense.
I think that makes sense to me. So let's do that real quick.
Just keep thinking about it for a moment here.
So let's do a let's go into our texture extension. So we're going to do the final thing. We need an alpha value. So our alpha value is going to do mathf.max, because why rewrite the wheel? Wow, that's a
that was
tongue twister. So
I saw just an AB.
This is exactly what we want. We just want this is int.
Yeah, we
have
want
a float one. Okay, good. Yeah. They do. So it's just it's going to be maximum of. Okay, they have a float A, float B.
Yeah, so that's perfect.
So decal pixel color dot A and texture pixel color dot A. And let's see if that fixed our problem. And to make this thing a little bit more visible and actually make it work like the other thing, I'm going to actually duplicate it. We're going to put our floor tile on one of these. And then we're going to take the one that's smaller and just make it slightly bigger. We're going to make it 5.01, 5.01, and 5.01. So now this is exactly like Valve does it. We're going to shoot, and it doesn't do anything for some reason. Okay, so let's not do both for right now. Let's just see what's going on here. Okay, it's working.
It is.
Sometimes it's not actually.
It's because your mouse pointer's actually off the window.
That's dumb.
Yes.
Okay, well, that was really dumb. We're just going to undo until we have what we had before. All right, let's give it another shot with my mouse pointer actually in the window. Did I make the wrong one bigger?
No, if you play it again real quick, maybe because look,
it shows up
you
there.
can see them
you can
on
see
the little image preview.
All right, let's make it just a little bit bigger scale-wise. Let's make it a whole 0.1. And let's make sure that this one does not have the... We don't need this anymore. Oh, yep, it is definitely Z fighting. All right. So we just are still a little too close for comfort here. Actually, you know what's the problem? Here's the problem. This is going to sound really funny. I bet you if I make this just diffuse, the problem will go away.
Let's see. Yep, that's absolutely the problem.
It's because depth sorting is much pickier for transparent objects. And so so since they both were transparent, they had to deal with depth buffer fighting. So yeah, there we go. We have it. It's actually now slightly above, you can see, and actually we can probably get away with much closer now. So let's see if we can do the 0.1 like we did before, which is probably close to the ratio that they have on the Valve models. There we go.
Yeah, that's
looking pretty buttery right there.
Now, if you back away a whole pretty far, will that depth buffer start Z fighting?
It shouldn't. It should be okay. It should be a good boy.
It
now.
Looks good.
Still works here too. But yeah, so now we have something that matches the UVs, and we have a decal system that works on characters. I would say that was a pretty good episode. I'd say that worked out pretty well.
Pretty cool stuff.
So, and even everything kind of works right. So, no statements about how fast this will run. It shouldn't run, like, the rendering portion should run just fine. Like, once this is moved to the texture, whatever you're rendering it on, if it was it's rendering the same amount of textures that it was before. But, performance-wise for the actual operation may be slow. So if you get a chug on, like, iPhone 1, I'm sorry. I'm not sure how it'll work. It might be just fine. I haven't actually tried it, but this is a way that you can do real decal systems, and you can do either the layer above or just put it right on the texture. There really isn't.
Yeah, I mean, if you're having an issue with performance because of transparencies,
I would say just do it to the texture in general. The reason that Valve does it the other way is it allows them a little bit more fine control of things, but it probably doesn't matter in most usage cases.
Well, I mean, we did see an issue actually when we were playing with Gary's mod where
oh yeah, reset everything. Yeah, totally cleared all
everything.
it didn't happen on the show, but yeah, we did a little test earlier.
And I'm assuming really cool. that is probably why they do it the way they do it, so they can clear it if they need to. That is pretty cool.
Valve's decal system, actually, here's some homework for you guys. Valve has a really cool. You should shoot a can in Half-Life a few times and in the same place, because one of the things they do is they have their decals have a height map on them, and so they have like a height type thing, and they actually render the height map additively so it gets deeper looking when you shoot a hole multiple times. It's really cool. That's stuff to look for.
That's pretty neat.
Anyway, I'm going to call this a wrap. Thanks for watching the show. You should buy and download Phil's game Automation.
Yep, and you should download Proton Pulse.
And I guess we should usually do this before this, but my email is pushypixels@pushypixels.com. Please email me. I'm very friendly. I don't bite. And Phil, if you actually let's do my Twitter.
Yeah.
My Twitter is at Dracfire. And Phil.
I can be reached at philip@protosoftworks.com. I'm also on Twitter. And as I said last episode, and I say every episode, I really, really like followers on Twitter, so you should totally follow me.
What's your name on Twitter?
Magmalemur.
Okay.
At Magmalemur. Oh, I forgot about that, didn't I?
Yeah, you did.
And yeah, buy my game. Buy Max's game.
All right. And thanks for joining us. Hopefully you enjoyed the episode.
Yeah. Have a Death Star.
Have a Death Star.